Hi guys, welcome to Unit 9, Lesson 3, Random Sampling. So first off, random sampling is a small section of a statistical population selected without specific aim. So in my last video and in your last lesson, right, like that question about surveying people who bring their lunch, right? So there was no specific aim with that answer because we selected people at random in the lunchroom, right? We weren't, there wasn't a specific aim for just talking to females or just talking to people from a certain club or anything like that, right? It was random. Bias is the tendency of a statistic to underestimate or overestimate a parameter, okay? So a bias might be like, let's say you want to know who's angry about, I don't know, a new flavor of soda at Chick-fil-A or something, right? Like that, right? And you only talk to the people who are angry, right? That's bias, right? Because they're already angry. Of course, that's gonna be their answer, all right? So that's just a random example of a bias. Let's talk about some examples. Number one is also number one on your quick check. A store is conducting a customer satisfaction survey. Which of the following would most likely lead to a biased sample? So we're looking for the one that is biased, okay? So let's look at the different options. We've got selecting 100 customers from a customer list at random, selecting every fourth customer who comes in the store, selecting female customers who purchase an item, or selecting random customers at the checkout. Okay, so the thing that I want you to notice is that only one of these has bias in it because it has a specific type of person that they're asking, and that's this one. Okay, the other three are all random to some extent, right? Selecting 100 customers from a customer list at random, right? That would not be biased. Selecting every fourth customer who comes in the store. You can't control who comes in the store and the order that they come in. So again, that's random. Selecting random customers at the checkout. Okay, so this third option, which I don't know if it'll be the third option on yours or not, but for me it is, selecting female customers who purchase a specific item, right? There's a lot of bias in that, not only based on what they're buying, but also that they're all female, okay? So that would be your answer for that one. Number two is also number 4 on your practice. A middle school has 450 students. In a random sample of 100 students, 8 students indicated that they have traveled outside the United States. Predict the number of students at the middle school who have traveled outside the U.S. Okay, so again, they took a sample of 100 students, right? And 8 of them, so we could say 8 out of 100, right? We can use a ratio for that. Okay, and that's representing the whole population. Well, we can use a proportion to help us figure out, well, how many would that be in the whole school? So the whole school is 400, right? So this is the total sample. This is the total number in the school. On the top of each of my ratios, I've got the people who have traveled outside of the United States, and that's what we're looking for over here. We'll use X for our variable. If you can notice, okay, what could I multiply by to get from one side to the other? Awesome, go ahead and do that. The other option is you could reduce this and then multiply, or you could use cross multiplication. It doesn't matter which method you use. For this, one thing I noticed right away is that like 8 can be divided by 2, and so can 100. So if I do that, I could rewrite this as 4/50ths, and then 50 times 450, or no, just kidding, 50 times something gives me 450, and that would be times 9. So I should be able to multiply the 4 times 9 to get to my variable, which is 36. So we could assume that about 36 students have traveled outside of the United States, from the whole school. Number 3 is number 1 on your quick check. A store manager wants to know the percentage of shoppers who use coupons. He surveys everyone who enters the meat aisle. He finds that 60% of shoppers use coupons. Does this method support a valid inference? Okay, so let's look at the first sentence again. A store manager wants to know the percentage of shoppers. So that means anybody who comes into the store, do they use coupons? Okay, so we have to think of that in our minds, right? Or we have to keep that in the back there. So, and he surveyed the people who enter the meat aisle. Well, if he only surveys the meat aisle, one, he's only covering people who eat meat, right? What about vegetarians, vegans, right? People like that. He's also going to miss out on people who maybe came in for like one item, or maybe they just didn't need meat that day, right? So he's missing out on a really large amount of people who represent the total amount of shoppers in his store. So first off, we can automatically eliminate the answers that say yes, okay, because he is being biased. So we'll eliminate those. Next, we have to figure out the reasoning, okay, so does this support a valid inference? No, right, and let's figure out why. This first one says because the sample is not chosen randomly, right, he didn't go random, he went straight for the meat aisle. Or no, because not all who enter the meat aisle use coupons. Well, that's the point, right? Is he's trying to figure out who uses coupons and who doesn't. So that doesn't make sense. This first one, it's based on that randomness that we need to focus our samples on. Okay? So that would be the final answer there. All right, as always, if you need extra support, just let me know. Otherwise, have a great day.